Welcome to Study Loop.
Our question says that on mountainous downhill roads, escape routes are sometimes placed to the side of the road for trucks whose brakes might fail. Assuming a constant upward slope of 26 degrees, calculate the horizontal and vertical components of the acceleration of the truck that slowed down from 110 kilometers per hour to rest in 7.0 seconds. Okay, so I wrote down here what we were given in this problem, and that is that the initial velocity v of 0 is 110 kilometers per hour, which I can convert into meters per second. I do that by using the fact that there's 1,000 meters in a kilometer and 3,600 seconds in an hour, so it's 30.6 meters per second. And we also know that the final velocity, v sub f, is 0 since we come to rest, and that's after a time of t equal to 7 seconds on a ramp theta 26 degrees. So we're going to use our equation for the final velocity, which is equal to the initial velocity plus the acceleration times the amount of time that acceleration is applied. Okay, well, we want to first find acceleration before we can find the horizontal and vertical components of that acceleration. So we rearrange this equation to solve for acceleration. That is equal to v final minus sign first, minus v initial, all divided by time. Okay, well, v final was 0, v initial is 30.6, so this is minus 30.6 divided by time, which is 7.0, and this is going to be in meters per second squared. Okay, and if you do this, it comes out to be minus 4.37 meters per second squared. Okay. Now that we know the total acceleration, we can break this into the horizontal and vertical components we were asked to find. So the horizontal component, which is a sub h, is going to be equal to the acceleration times the cosine of the angle. So this is minus 4.37. And then this is times the cosine of the angle, which was 26 degrees for the ramp. Okay. And if you plug that into your calculator, you find that this comes out to be minus 3.9 and that's meters per second squared. Okay, we can box this in here because this is our solution for the horizontal component. Oh, blocked out the square there. Next, we want to find the vertical component, and to do this, we're going to use a similar method for a sub v for vertical, and it's going to be the acceleration now, but this time times the sine of theta, since it's the vertical component, not horizontal. Okay, and again, we're going to plug in minus 4.37 meters per second for A and 26 degrees for theta, but instead we're going to be using the sine, of course, and this comes out to be minus 1.9. This is meters per second squared. We can box this in as our solution to the vertical component.